So today, what we're going to do is talk a little bit about wearable computing, and then we'll have a small break for coffee, and then we can try some hands-on work. Then we'll have another lecture about the user interface, user experience with Google Glass, and we'll have some lunch break. And then we'll talk about some tools for designing, and there will be some time in the afternoon for about a couple of hours for starting to design your own concept for application. So the goal during this week is that each person should be able to build one Google Glass application. And you should be able to have applications you build. So each day we're basically going to have in the mornings normally lectures, and the afternoons is kind of hands-on programming time. Gun or myself or Hudon will help you with the programming. And then at the end of each day, we'll have some time for kind of discussion or review about what we're doing at that time. So the goal for today is to learn a little bit about the history of wearable computing and a bit more technology background to Google Glass. Talk about the user experience and some tools for very rapid, quick concept designs, and then to also begin some application design. So, does anybody have any questions so far? Questions? Great. And I should apologise for you, Wei-Ping. Some of the slides here you have seen before, because some of them from AWE, but we're going to expand a lot more from that. Because AWE we had 3 hours, now we have 5 days, so we make it much bigger. So that's good.
AWE stands for what?
There's a conference which is held in the US in June, and AWE is Augmented World Expo, and I can show you. So they just had before, and if I go to here, and so AWE 2014, they have this conference here, and actually wow.
The one with volume clients, the one client is playing.
Which one?
The one with volume client is.
Oh, okay. Thank you. So this is the AWE conference here, and it's already finished. It was in June, but the good thing is though that you can still go and see some of the videos. So here's some of the videos of different speakers.
So this conference will happen in the US every
year, yeah. And it's basically a kind of industry conference. So they have about 1,500 people who came this year, and many short talks, and not so much on the technology side, but some on technology, but mostly about the industry and the applications for augmented reality, and not just augmented reality, but also 3D printing and digital content and so on. Yeah. Okay. So let me, and as part of this, I gave a tutorial on building Google Glass applications. So let me swap over now a little bit to all the history. And, so, as I said, all the slides that I'm showing I will make available to you, and there'll be some other material I can make available to you as well. So as we go through, there are some research papers, these are the things I can share with you too. Okay. So, a little bit about wearable computing, but first, before I start about that, I'll talk about clocks and timepieces. So it turns out if you want to tell the time, 500 years ago, if you're really lucky, you would have a clock in your city or your village. And then over the course of the centuries, you see clocks have gone from being one per city, then there's a carriage clock, this is one per house, and then in your pocket, and then finally 100 years ago onto your wrist. And so the trend has been that the devices have become smaller, cheaper, and they move from public space onto the body. And the same thing has been happening also with computers. So you can see that there has been a trend towards going from large computers. This is the ENIAC computer you would stand inside, to this is the portable computer, compact local computer, to the PDA. And so you've also gone from big fixed computers to handheld. And now we've gone to the wearable. So you can see there's been some major changes in computing platform. It's gone from being room size to desk size to something you put onto your lap to maybe 10 years ago in your hand, and now with Google Glass, something that's on your head. And devices like Google Glass introduce the first really wearable computer. So I want to talk a little bit about what a wearable computer really is, and then I'll give you some history a little bit about that one as well. So one of the very famous researchers in the field is a man called Bradley Rhodes, and he defined a wearable computer like this one. So he says a computer is it's portable while it's operational. You can use it without hands-free or hands limited, so you can use it while your hands are busy. The computer is able to get your attention somehow, and so it's always on, and it also is able to somehow detect your surroundings or what's around you. Real with a virtual world, but you cannot see the real computer anymore. What we're going to talk about this week is mainly the fourth one here, called augmented interaction. So the idea here is that you interact with the real world, but it is mediated or modified in some way through the computer. So augmented reality is a classic example of that, where you see the real world, but what you but your view of the real world is modified by the computer. So if you think about augmented interaction, augmented reality, then you can arrange it kind of on this continuum here. So this is a line that shows how much of your real world is modified by the computer. So at the right hand side, you have an immersive virtual world. So everything in the real world has been generated by the computer, 3D graphics. And on the left hand side, the computer is not changing anything. And in the middle of this is where you have augmented reality. So you have small parts of your real world are being replaced by computer graphics. Or you have this augmented virtuality, where you can have most of your world replaced by computer graphics, and some pieces being replaced by views of the real world. Professor Steve Mann also introduced this idea of mediated reality, and this is the idea where you can place parts of your real world by computer-generated content and modify the view. So, for example, here is a billboard on the side of a road, and what he wants to do is remove the advertising from the billboard and replace it with digital sign. So it's mediating or modifying your reality. And I showed you before the mixed reality continuum from Paul Milgram. Well, Steve Mann extends this to talk about the mediated reality continuum. So here's on the bottom here is the mixed reality continuum going from the real world to the virtual environment. And then he said also you can have a mediated environment going up the side here as well. And so you can build this 2D taxonomy. Okay, so that's a little bit description of what wearables are about and kind of how they interact or some way to classify them. I want to talk a little about the history. And we've kind of gone through 4 phases. So the first 20, 30 years, there was a lot of early exploration and people building custom wearable devices and doing some early research. Then for the 90s through the early 2000s, it's more focusing on academic and military research. One of the very important things was that in 1997, the ISWIC Wearable Computing Conference started. So if you want to do more academic research, then the ISWIC conference is a very important one. And then also there's the ISMAR conference, which is the AR conference. Let me show you a little bit. the website so you can see. So we have, you can look for ISWIC 2014. This conference is going to be in Seattle. So here is the page for it. So ISWIC 2014. This is going to be in Seattle in September. This is September 13 to 17, and this is a normal academic conference. So you have the kind of workshops and things that you click on, so they show different things happening. So there's lots of interesting workshops that are running, and then they have a whole list of academic papers as well. So I don't think the program is up yet, but they will have a program as well. And so this is the conference for wearable computing, and then there's also the ISMA. So you got ISMA 2014. ISMA is the conference for augmented reality. And this one is going to be held in Germany in September as well. So it's a bit bad timing because this one is being held just before the course on wearable computing. So once you go to Germany and then fly from Germany to Seattle, and you can do both conferences. But yeah, if you want to go for augmented reality, then this is the number one conference for augmented reality. So both of these conferences started about the same time in 1997, 1998. And then in the 1995 or so, you started seeing the first commercial uses of wearable computing. These computers in those days were quite big and bulky, so they were very easy to wear. And so these ones are mostly designed for military or some very niche applications. And then in 2010 or so, we're starting to see the second wave of wearables, which is Google Glasses. So now we've got computers that can be worn on your foot. So let me give you some brief history, and then you can see some more. So one of the first wearable devices that was developed was by Thorp and also Thorp Shannon. Thorp Shannon is a very famous professor from MIT who was a communications theorist, and dead now, but in the 60s, Ed Thorp and him partnered up, and they built a wearable timing device for predicting the roulette wheel. So when you go to the casino, they have the wheel that spins around and you can drop the ball in. So in this case, they figured out that if you could measure when the ball was dropped, you could predict fairly well what numbers it would fall on, because if you could measure the time. So what he did is he had a small box that he carried, and he had an earpiece that he wore, and then the box, when the ball was dropped, he would push a button for the drop, and it would tell him what number that he should be betting on. And in those days, it wasn't illegal to bring devices to the casino. Then about 10 years later, Keith Taft built a more modern wearable computer. This one has almost everything that we have today in wearable devices. So, for example, he had a belt here, so he wore his computer around him, a belt. And then one of the challenges of wearable computing is how do you provide input, because you cannot have keyboard and mouse anymore. So he had a shoe input system. So in his shoe he had electronics and some buttons, and he would push the buttons with his toes. This one was designed for blackjack, so counting cards and blackjack. So when people would enter the cards, he would push the buttons with his toes to keep count of the cards. Then you have to have some output, of course. So he had some glasses here. The glasses had a small LED light inside them. So it would tell him when was a good time to make a bet, keeping count of the cards. So you can see it's very primitive, but it has almost all the components that you would have in modern wearable computer. You have the processor, you have input, and you have output. So this one worked well for him. One weekend he was gambling and he won more than $100,000 in one weekend. But unfortunately, the casino found out, and the next weekend they arrested him. So that was the end of his gambling. And then a little bit later, Steve Mann started doing wearable computers. When he first started, it was he was using it for photography. So he was carrying a camera and computer around with him. And then he started doing videoing. So in the mid-90s, so early 90s, he would live stream video from his head onto the internet. So if you went to his webpage, you could see live what he was seeing. And then now it's kind of a system in the late 90s. But Steve Mann did his PhD at the MIT Media Lab. And so in the mid-90s, there was a small group of people doing work on wearable computing. Steve Mann on the left-hand side here. And then on the right-hand side, in the black, you can see another researcher called Thad Stana. Thad Stana is very important. You'll learn more about him in a minute. But from this academic group at the MIT, it was very inspirational for many people doing wearable computing research. There were some enabling technologies they had at that time that made it possible for them to do wearable computing research. So one was the reflection technology's private eye display. So you can see the person wearing one here. And this was a red-only display that was made from red LEDs. It had a vibrating mirror, so it had a line of LEDs and the mirror would vibrate and it would shine the LEDs onto your eye. So it had a 720 by 280 resolution display. And so when you look through, it would block one eye, but you would see the real world with your other eye and see the overlay. And the second piece of enabling technology was this what we call Twidler by the Handy Corporation. And this was a handheld input device that fit a whole keyboard into the palm of your hand. So it was a chording input device. So when you push several keys together, then you could create all normal keys on a keyboard. So with these two, you had the output and you had the input. And then, of course, you had a processor. So then they made their own processor called the Tin Lizzy. This was named after Henry Ford when he made his first Model T car. It was called the Tin Lizzy. So Thad Stana, who I mentioned before, and Doug Platt, they made this general purpose wearable computer, and the idea was to make a computer that anybody could carry around with them and customize very easily. So it had a 150 megahertz Pentium CPU, small amount of RAM, hard drive, plug-in for VGA display, some PCMA slots, and cellular modem for connectivity. So here is Thad Stana. In 1998, he's wearing his reflection technology's private eye. He's got his Tin Lizzy on, but he's also using a regular computer as well. So in those early days, people developed many different types of computers. So here is this is a man called Greg Stillman, and he has a recording keypad. He just used to have a computer that only had audio in it, so he would type and he would hear spoken to everything he was typing. Here's another man with some set of cameras on his head. Here's a more industrial computer as well. So the early technologies involved normally a belt or backpack for carrying the computer, and then some sort of display like head-mount display or LCD panel, some input devices, and some networking as well. The US military also started getting involved in wearable computing quite early on, and they first of all developed early experimentation using 386 computers, and they used the computers mainly to show some mapping or some GPS information. Then most recently they've been using this Land Warrior program. The Land Warrior program is still ongoing now. So they use an integrated wearable system with a camera, colour display, and radio. So you can see here the soldier's wearing the Land Warrior with his gun. He has a monocular display here, and it's used for things shown at navigation reports or taking pictures. In the early 90s, Carnegie Mellon University in the US was also involved with wearable computing. They were focused more on the industrial applications and on industrial design of the wearable computer. So using computers for maintenance and repairs. Actually, some of the applications you've been thinking about, Derek, with datacom, these would have been the ideal for Carnegie Mellon. So they built some custom design inputs. So you can see here they have a wearable computer. They have a dial for showing for capturing user input, and also a special button system. Here's a flex technologies again, and they use it for maintenance and repair. So here's a person doing a repair task, and the computer is showing him the diagram he's repairing. So they had many generations of different computers. So you can see a whole set of different wearable computers here with many different specifications. They had starting with 8 megahertz processor and then going up to 486, 33 megahertz processor. And beyond that to Continuum. This also led to some early commercial systems. So here is the Zybernaut computer. This cost about $5,000, and it had a 200 megahertz PT minute, and this monocular display system here. Then there was something called VIA that made a computer that was an audio-only interface. So you wore this computer with headphone and speech recognition. And the idea was to use this for stock picking. So if you have a warehouse, then you might need to want to, like if you work for Amazon, you have a huge warehouse, you might want to pick objects off the shelves. So this one used audio input for that one. And then Symbol Technologies, they make a lot of barcode scanning devices. Actually, some of what you guys use is made by Symbol. And so they also made a wrist-worn computer. It turns out it takes some time to take the barcode scanner from your holster and then scan. So if you have the scanner on your finger, you just point and finger scan. So this is running a DOS, and it has the finger scanner, and then on your forearm here, you would have a small computer that would capture input. And they manufacture many of them. I think this is still available, I'm not sure.
Yeah, it's not called Symbol anymore. It's the it's called the Symbol is just called yes,
okay.
Yes, it's called wrist scanner.
Wrist scanner.
Yeah. No, it's still running Windows CE. CE 5 or 6.
Okay. So those are some of the early commercial systems. Of course, people also had to develop some different applications. So when you start wearing the computer on your head, it enables new classes of applications. So here's some examples. So one interesting one was by Brad Rhodes. I talked about before, Remembrance Agent. And the idea of this one was if you could monitor what the person was typing on their computer, then you could provide text to help them, text prompts to help them. This is a Emacs window, and as the person types into the window, these bottom 3 lines here provide suggestions for articles or other files stored on their computer that might be relevant. So as you start typing away, you'll see these lines of text changing as it's pulling out information that might be on your computer that's relevant to what you're doing. So they call it a remembrance agent because it acts like kind of long-term memory. Everything on your computer becomes indexed, and as you type through it, you write a search. Then there are some people who have been using wearable computers for augmented reality, and we'll talk about that in a minute. Also people using for remote collaboration and maintenance tasks. This is a person that is a factory worker in the US. So they're working in a chicken factory. So they use the wearable computer for keeping track of tasks as well. So one of the areas that people use it for is for remote collaboration. So the idea is if you can wear a computer on your head, then you can have a camera and microphone, and you can stream that to a remote person. The remote person can see what you're doing and provide some feedback, so that you can have a collaboration between the user and the remote expert. So British Telecom was doing some work on this, and then also Carnegie Mellon was doing some work on this one here. I have a video to show of this one working, so let me just put the video up.
Sorted. I'm going to have a look at the chair.
Paramedic Keith.
So I'm just going to rewind a little bit. This video is quite old video, so it's small. What you'll see here, though, is a person who's a medic who's arrived at the scene of an accident, and he's streaming the video to a remote doctor to help him.
Sorted. I'm going to have a look at the chair.
Paramedic Keith Hotchkiss wears a headset with a mini TV in front of his right eye, a microphone, headphones, and a mini camera. He's linked via satellite and special telephone lines to the hospital.
Okay, Alan, did you hear me?
Yes, I can.
Right, we've got a 35-year-old gent involved in an RTA, fronting pack, high speed. He's complaining of difficulty with breathing, and the trachea is swinging to the left. I think this gent's got a tension pneumothorax of his right side, so I'm going to decompress it now.
Yeah, you're going to have to put a drain in. Have you done one before?
Only on a mannequin.
Right, and what am I going to do?
Consultant Alan Jones in Accident and Emergency can guide the paramedic through the procedure, sending a diagram of the chest to the TV screen in his headset.
A picture of a chest. See the chest?
Yeah, got that.
Drop to the second intercostal space where my arrow is. That's where you'll need to put in a brown gauge cannula.
Going in now. Okay.
Great. So you can see the medic was able to share his view with the remote doctor. The remote doctor could then point on what he was seeing and display and provide some feedback. Another application area is augmented reality. So many people have started doing work in that space. But in the late 90s, one of the first mobile augmented reality was this one called Turing Machine by Steve Feiner from Columbia University. And they were wearing a backpack computer with GPS and with tablet, and then they had a see-through head mount display on, so it was all wearable system but using two computers. As they walk around the real world, then the idea was to superimpose content onto the real world, right, augmented reality view. So this is what they would see in that case. So here is looking at the real buildings and seeing some text superimposed on top of the buildings. And so it provides you kind of information in place, or information in the real world. And there are many examples of similar backpack systems. So this is one from Wayne Pikowski. And Wayne was a student at the University of South Australia, and he built, he liked playing computer games. So his idea was that he could go out into the real world and play the computer game in the real world, play Quake. So here he is in the real world with this Quake game, and here's all the backpack stuff you have to carry. And at the HIT Lab, we built our own system as well. So we worked with the local company Trimble, and then they provided very highly accurate GPS tracking. So they're able to track down to just a few centimeters the location of the real world. And we use head-mount display to, with a video see-through head-mount display to share the content of the real world, and we use a laptop as well. So this was used for what they call a stakeout application. So when you do surveying in the real world, you oftentimes have to put wooden stakes in the real world to show where the boundary of a road is going to be, or where the building footprint is going to be. And so normally they have you'll see people with a pole, with a GPS on the pole, walking in the real world. But with our system, you can look around and you can see put into the real world virtual lines showing you where the content is supposed to be. And we found that by doing this, people could complete the staking out task by took half the time to do the task. So let me show you a video of this one working. And so.
A collection of New Zealand's weird and wonderful inventions is being showcased at an international event in Christchurch. Science ministers from APEC countries are meeting for a conference this week, and they'll get to see the best of Kiwi science and technology talent.
Oakley might look a little out of place. That's because he's entering.
So you can see he's wearing a backpack system. When he looks in the real world, you can see a life-size house here in front of him. And so it enables him to walk through the house model and see the content fixed. So here's the system here. It takes backpack, and then as you go inside the house, you get the complexity of the 40 windows outside, so it's really life-size 3D building. And so you put the camera on, there's a camera behind there. So, however, this requires quite a lot of hardware. So you have all this stuff on your back, so you can see the backpack computer here. This custom built wearable computer. You have a lot of batteries, battery converters, 2 different antennas, and so forth. I think this slide is already showing, but that used to be what you had to have in the mid of 2002, 2003. But then in 2008, you started having the first mobile phones with similar sensors. So the Motorola Droid and then the Nokia Navigator have GPS and compass in them. So now with your mobile phone, you can do a similar thing as a backpack, but in the palm of your hand. So the phone also allows you to do real-world information display, so combining GPS and compass, overlaying the graphics onto live video, and there are many applications, so for advertising or travel guiding, etc. So a number of companies are working in this space. One of the most popular is a company called Leia, and Leia allows you to take your phone, look around you, and see virtual information superimposed on the real world. I want to show you a demo of this one, but it's running on my tablet here, so let me just start this up. I can pass it around and see what that would look like. So, okay. So this is not using Layer. This is another application called Genio. But as you look around, you will see Genio a number of icons appearing here. And these icons show different points of interest around you. So for example, it says 80 meters this way is engineering campaign. If I go this way, you can see there's a high school over there, about 2 kilometers. So I'll pass it around. You can try for yourself. This is a typical. This is called Genio, Junio, and it's a typical handheld augmented reality application. So this is an augmented reality browser, so it's free to use. And then if you just have to develop the web content, you can put onto the web as well.
There's something.
Oh, can you bring it back? It says scanning for. I don't want to do that one. I think what happened is you have to. If you touch by mistake here, it will go to scan mode. You don't want to go to scan mode. Then, so change from this is the AR view. Change. Change. So here's a map here. Change back to I'll pass it around. So just don't, if you push the scan, then it will go to the scanning mode, but just push it again to go back to the AR view. That is kind of typical for handheld AR application. And Leia is very popular. I think it has about 40 million downloads and installs. And for a while, when you bought the Samsung mobile phone, it comes pre-installed by default onto the Samsung phone. So if you look around, you'll see the points of interest all around you. So if you're going to a new town, then this might be helpful for you to find a restaurant or some other.
Does it use GPS? The actual GPS?
Yes, it uses GPS and compass. Yeah, so it knows where you are looking. So it says
fractions of the.
from compass.
I think you're wrong.
Yeah, the iPad has a compass in it. So as you turn the iPad, it knows which way you're turning.
Oh.
So the iPad has a compass in it. So it knows exactly where you're looking. And so the GPS provides position, and then the compass provides the orientation. If you have Android phone or iPhone, you can download and try for yourself. And Derek, if you touch on any of those icons, then it will also put up more information as well. And you can go to the website and there are many other applications.
You should be able to filter through.
Yes, that's right. You can provide some filter based on distance or other things as well. And there are many different applications that they use. So you can subscribe to different information channels, for example.
Thank you.
Also, if you have iPad, that's great. If you have Windows Mobile, then the Nokia has something called City Lens, which is similar products. So that's the handheld AR. And so over the last 10 to 15 years, there's been this kind of evolution in mobile AR platforms. So you started off by having some handheld platforms, and then about 2000, you had PDAs could run kind of thin client applications. And by 2005, the first self-contained AR was available. The first backpack computers were about 1997. Then about 1998, you had the first cell phones with cameras on them. And they all combined together, so now you have a cell phone with camera and with sensors and a wearable computer. And so this kind of represents 4 changes in computing platforms. So before from desktop to laptop to smartphone, and now finally to something on your head, which brings us to the.
What do you think is next invention technology after glass?
Well, I think that's a good question. I think, for starters, this will become more unobtrusive. So this is on your head, but people are now starting to look at making contact lenses to be in your eye. And people are also looking at implantable computing as well. So already you can have pacemaker that has some timing and electronics in it. So I think in the next 20, 30 years there'll be more devices that are implanted inside the body. And also,
So that means we can develop something to help blind people.
yes,
Yeah.
yes, there's already people working on implants for the ocular or nerve, so they can help people see. So this is the Google Glass. So I have one here. Actually, it's the white one here. It's easy to show probably. So the Google Glass display is basically everything in the wearable on a cell phone shrunk down to fit into the side of the device here. So we have 3 main parts. There is the battery, the backside here, and the bone conducting transducer sound. The second part is the processor and touch input. So here we have a CPU, and we have some sensors, just like your mobile phone, motor sensor, accelerometer, and then a long touchpad from here to here, touchpad. And the third part is the micro projector at the front here, and camera and microphone. So the micro projector works by projecting image sideways and bouncing off the reflection on the back end there and into the eye. So when you wear Google Glass, you turn it on, you touch it by turning on, and then you will see in the top right hand corner of your view the information display. So this is kind of the view you get very, very well. So it's it follows those basic properties of wearable computing. So it combines computing, communications, and content. So it's always on, always available. If you were to split it apart, then what you would find inside is that you have this 1 gigahertz processor. You have about 16 gigabytes of RAM memory, of flash memory, sorry, and 1 gigabyte of RAM, although they've recently doubled this to make it 2 gigabytes of RAM. And then a small battery, you have a camera, a 5 megapixel camera, 720p recording microphone, a set of sensors on here. Also for output, the bone conducting speaker, and also set for micro display, 640 by 360 display. So, actually, I wanted to show this a bit later. This is about prototyping, but what I want to talk about first of all was the evolution of Google Glass, and then I'll talk about this in a minute. So this is what we have now, but it took a long time to get there. So people have been working for about 3 years to build the early prototypes. So you can see here's some early different prototypes that we're making. Actually, yeah, maybe we'll show this video. That might be helpful for you. So, just get the video for you. And, okay. Find the video. Back to here. Okay, so this is a video from Tom Chi, and Tom Chi is a he's working at Google, and he was one of the original designers for designing Google Glass. But the video is very interesting because it talks about how quick it took them to prototype the first version. So, do you have any ideas how long it would take to make the first? So the idea of glass is to be able to project information, make it appear in front of your face all the time. So how long do you think it would take to make that first version? 5 or 6 years, okay. Does anybody else have any other idea? 10 years, okay. Well, it's actually much quicker. So let me just, so it took, to make the first version, it took 1 day. and then, so you have to think, well, Tom Chi is designer, so the idea of design is you know, you don't want to spend 5 years on a project to figure out that actually doesn't help you very much. So he said, okay, well, let's test it very quickly and see if it works. And then if it does not work, we won't do it. So it saves some money and time. So this is kind of a longer video, 8 minutes, but it gives a good overview of the prototyping with glass. So this is a TED talk he gave for the TED education. And sorry, it's unmute.
Place called the Department of Science Fiction because of the.
Let me just go back to the beginning here.
My name is Tom Chi. I spent 2 years of my life building the user experience team for the Google X division. And it's a place I affectionately call the Department of Science Fiction because of the futuristic nature of the types of projects we took on. Self-driving cars, Google Glass, and other things that you'll see soon enough. So, for those who haven't heard of this project, this is what Google Glass looks like. It allows you to overlay digital things into your eyesight while still maintaining being part of the world. So if I, were to pull out my cell phone and look into it, I'm basically out of this world now. Like I'm in my own little cell phone, tablet world, what have you. But Google Glass has the vision of allowing us to continue to be in the world, but also have access to the digital things that we need and we love. Now, I'm going to ask you a really simple question about Google Glass. How would you prototype this experience? How long do you think it would take you to make the first working version of a headset display? Okay, a little bit on the long side. The answer is 1 day. And here's what it looked like. So basically, the magic piece is the coat hanger. The coat hanger, I bent it in a specific shape, and the top loop goes around your neck, and then the bottom loop rests against your chest. It allows me to carry a piece of plexiglass on which a little sheet protector. So these are the things that you put your book reports in so they don't get wet. Literally got it in the drugstore. Have it out at the end of the plexiglass, and then it gets projected onto with the Piper projector that's connected to a netbook. And using this setup, within 1 day, we were already able to start having the experience of what it looks like to have digital things overlaid on your physical world, be able to move around with it, and also use the netbook to try out tons and tons of different ideas around software. Now, after you start getting something like that working, a really important problem comes up. Like, you're wearing this thing on your head. It's like a pair of glasses, so you don't have a mouse or a keyboard or a touch screen, all the ways that you're used to interacting with a machine. So we thought for a second, well, maybe we could do something like what was shown in Minority Report. So for folks who haven't seen that, basically Tom Cruise is manipulating software with his hands in front of his face, and photos are flying over here, and his emails and over here, and so on and so forth. So that's the same question again. How long do you think it would take to have the real experience of doing something like that? 2 years, okay. Somebody said 1 day, 45 minutes. So here's how it looks. So you wear the thing that we saw the first time because you need some way to go project things. But what happens is we got 2 hairbands, which I think was the hardest part. We had to go ask people for their hairbands. But you put one hand in each hairband, and attached to that hairband, we tied a fishing line. And the fishing line goes over the top of the whiteboard and then goes down to this little assembly that's taped to the floor. And what this means is every time I move my hand in any direction, it adds tension to the line. And it does the following with the assembly on the floor. So the other end of the fishing wire is attached to a chopstick. And it's not because I'm Asian, there's just a cafeteria nearby. I don't just carry chopsticks on me. But I tied it to the end of a chopstick, I clipped it into a binder clip, and then put it over a pen. And basically what happens then is when you move your arm and it produces tension on the wire, chopstick comes down like a lever and clicks the presentation clicker. One hand moves the presentation forward, the other hand moves the presentation backwards. So this was built in 45 minutes, and that meant shortly afterwards, we're having experiences like looking at an image gallery and saying, next image, previous image. Or looking at our emails and saying, let me click into this email. Let me click reply now. And this was exactly the experience of what it was like to go control software with your hands. And ultimately, what it taught us is we probably shouldn't have this in the product. We learned a lot of things about the social awkwardness of it and some of the ergonomic aspects of it that you couldn't have figured out ahead of just thinking about it. And ergo the second prototyping rule, which is doing is the best kind of thinking. They teach you to think a lot in school, but I think it's a little bit overrated. Now, last example, actually Google's not the first team that's tried to go make something like this. If you search for heads-up display, you get tons of images of teams that have built various systems like this, but I can tell you at a glance that none of these pieces of hardware are comfortable to wear for more than 15 minutes, except for maybe the helmet over there, but then you gotta wear a helmet. So, how would you go figure out a way to go wear something like this comfortably? The answer is really basic materials. Modeling wire, paper, clay, and using something like this is able to make something that looked like a pair of glasses really quickly. I cut out pieces of clay that weighed exactly the same amount as the electronic components that we were talking about putting on the device. Wrapped it in paper so you didn't get clay on your face. And then taped it to the modeling wire in various places to go experiment with how a pair of glasses can fit on you. And we discovered something really important then. Like, if you look at this drawing on the bottom, it turns out that the weight of a pair of glasses is actually mostly perceived through how much weight is on your nose. And it also turns out that your ears can carry a lot more weight than your nose. And that's a totally different experiment. You could ask me about that. But because of that fact, if you put weight behind your ears, it allows your ear to go act like the fulcrum of a lever. And it then takes weight off of your nose on the front. And actually, you guys can try this now. Anybody with glasses, if you push very gently on the back of your glasses, you'll find actually your glasses feel tremendously lighter. Now, this meant that we not only discovered something interesting about how to go, that's useful for developing a device like this, we actually discovered something pretty fundamental that had never been discovered about glasses, period. So if you have really heavy glasses, you can do this and you will be more comfortable. Now, the last point I want to make is about 2 types of learning, because through the process of rapid prototyping, you're able to learn very, very quickly. It's a very specific type of learning. The type of learning that you usually learn in school, I call book learning. It comes from what humanity already knows, and it's a necessary foundation for you guys to go and explore the world. But there's a totally different type of learning, which I call expansive learning. And this is the learning that you do on behalf of humanity. Right? You are creating something new, you are expanding into the possibilities, and you're building that sphere of human knowledge in that process. And we think about these things, and as soon as you hear, the infinite realm of possibilities beyond the sphere of human knowledge, you might be thinking, well, there's the scientists at the Large Hadron Collider who have these amazing instruments. That's their job, right? But the truth is that this this action is available to all of us. You know, it's not just for the scientist, it's also for the poet or the songwriter that expresses an emotion for the first time in a unique way. It's also for the person that has an amazing business idea that they're certain can help millions of lives. And it's the realm of using paper, clay, and tape in order to go find a new insight in an ancient technology. So now that you guys know a lot about rapid prototyping, I'm excited to see what you'll do with it. Thank you.
So in that video, he talks a little about the journey to be making Google Glass, and so you can see that in some of the pictures here. So this is one of the first systems he talked about. So here is the coat hanger here. It had a plastic pocket, a folder projector. There's a little micro projector that projects onto here, and then this is hooked up to the network computer he's holding in his hand here as well. So now he could carry this around with him, and he got the feeling that he was seeing a image all the time. And then another variation here, wearing a bike helmet with a projector on it to also be able to see. And you see in this case he has also a glove on his hand, so they were still looking at glove input. Here's another early version as well. So that was kind of the first evolution, and this is about 3 years ago. And then here is Thad Stanner again. So the Google Glass project actually arose because Thad Stanner from MIT, he met Sergey Brin and Larry Page at a conference one time in 1998. And they were very impressed with him because he had this wearable computer on, he was looking a bit strange. So they asked him about it, and they started talking about wearable computing. And of course, they became the CEO, or Larry Page became the CEO of a $1 billion company. And so a few years later, they started Google X Labs, and wearable computing is one of the things they started doing. So they brought Thad Stanner in to work part-time now. He's wearing one early prototype. Basically, the first prototype was, in this case, they took a mobile phone, stuck on the side of the head. They still have the cables back here, and they have another computer on the backpack. So it was a display and a camera on the top. Pretty soon they got rid of the backpack. So this is you can see the weight here at 3,000 grams, so 3 kilograms. Now it's gone down to 167 grams. So they took the mobile phone and they split out from the phone a camera and display, and then they use a touchpad on the phone still for input. So here's the people split out on the phone here. Then now they've made a smaller version. Now the display, which is similar to the current version of the glass display. Then the final prototype, 68 grams. Now the one we have here, this is 46 grams, so very light. So here's the evolution down to you can see initially they were looking at building 2-eye displays. They got rid of that and turned it into a single-eye display. Yeah. So as I said, the system has the battery here, power LED, power button, touchpad, processor memory, another button for a camera, the gyros and accelerometers here. On the inside is a microphone. There's also an infrared sensor. So the infrared sensor on the inside here can detect when this is on your head or not. And then, of course, a microprojector as well. However, this isn't the only type of wearable display, and there are other competitors as well. So, for example, there's something called the Vuzix that makes the M100. This is are you able to get the M100 display? It's in your office, isn't it, again? Yeah. So this is available on the market right now, and this is more for professional applications. There's also the Recon Jet. Recon Jet combines more sensors and more for sporting applications. There's one called Opti Event. Event has multi-view mode, so this allows you to change the view angle, and then multiple multiple pieces for release. So let me just show you a couple of websites, and then you can see. So, for example, the Opti Event. They call it the Aura. Oh, thank you. So this is optinvent.com. You can buy this now. It's 500 euros. So, what this one has is a see-through display. camera on it, but you can also tilt it. So you can tilt it above or below the display. I think I have some more pictures here. So you can be having it, look right through the display here, or you can flip it down and you can look down the display and down mode as well. So you can see here, this is kind of looking down, and then you have this AR mode where you can look straight ahead. So it's quite a unique type of display where you can flip the display up and down. And this is the Music's M100. I'll pass it around a little bit. As you can see, this one just clips on the side of your head here. You can wear it like a pair of glasses as well, but I'll pass it around in a minute. This is different from the Google Glass because the display is fully occlusive. It's not see-through, it's just a display blocking right there. There's also a camera on the front here and a microphone, and it's similar same properties. And then we have the Recon Jet. The Recon Jet, or Recon, is more designed for skiing or for sports. So if I go back to my, you can see here's a video of the Recon Jet. This is the more modern version, and it's kind of displayed in a pair of Oakley glasses. Running, firefighting. So he's playing golf, and on the display you can see a golf course appearing. The doctor can see some higher information. Firefighter information. Technology. So one side is the CPU and the sensors, and the other side is the battery and the display and the camera and microphone and speakers. So it's similar to the Google Glass system, but it's all has a few more sensors and it's a bit more ruggedized, I should say. So people say that because of this number of manufacturers, and there's a quite large increase in projected market for wearable displays. So they say that by 2016 there'll be more than 10 million displays in the market, and they project that Google Glass will be an $11 billion market by 2018. That's a pretty high projection, so I'm not quite sure if they're right or not. They think that by the end of this year there will be more 800,000 devices sold, which I think is probably far too high. But I think Google has already sold about 40,000 glass devices. So they're already, halfway through 2014, they're tens of millions. That's the way they should say. But of course, wearable displays is just one type of wearable device. So they think that the wearable market will be very big because it's not just displays, but all the other different devices. So you have Fitbits, you clip on your wrist, you've got Google Glass, you've got things you wear in your ear, watches, and your dogs. So for example, there's the Galaxy Gear watches that you've probably seen, the Android watches. And then Nike has some Fuel Band or some wearable devices for activity monitoring as well. So there's this huge market of different wearable devices that are going to be coming on the market now and in the next little while. So just to summarize, wearable computing is really a kind of new type class of computing. It's one that lets you have a very intimate relationship with the computer. It's persistent, it's awareness and accessibility. It's had quite a lot of evolution over 50 years, from a big backpack to something that's get worn. And that enables some new types of applications, so things like collaboration or augmented reality. And there are many different devices that are coming, so they're often Android based, have some sort of sensors, micro displays, and so on. So I think we'll stop there for a few minutes. We'll start again at 11.